Hi, and welcome to this demo of ReadiAnalytics, a tool for managing fatigue across your entire organization. ReadiAnalytics is part of Ready, the 360-degree fatigue management information system, brought to you by Fatigue Science. Before we introduce ReadiAnalytics, let's briefly introduce Ready. Ready is for those who believe that fatigue management is a shared responsibility, and that everyone in an industrial organization has a part to play in fatigue management. Ready delivers actionable insights tailored to each key role in your organization and helps everyone work together to improve productivity and safety with the world's leading fatigue management information system. First, briefly, let's introduce the Ready score. The Ready score is at the basis of all products used throughout the Ready fatigue management information system. Sleep data is used in combination with circadian factors in order to provide a quantified prediction of individual fatigue. With Ready, sleep data can be captured from a number of sources, including compatible wearables, as well as various forms of estimates for times when wearables aren't worn. The safety model is a validated biomathematical model that analyzes all of the inputs around sleep data and circadian factors from an individual's roughly 10 days of sleep history. This includes factors like quantity, quality, and timing, as well as circadian factors such as the seasons, night shifts, and time zone travel. As an output, the Ready score is a single number that summarizes the impact of those factors on an individual's fatigue relative to a fully rested state. So at a score of 70, as you can see depicted by the orange area on the chart, one's fatigue is predicted to have an impact causing roughly 30% lower cognitive effectiveness, 43% slower reaction time, and 5.2 times greater likelihood of a lapse, which is closely related to a microsleep. When we look at real-world data, similar patterns emerge in industrial organizations. Time spent in the green is more productive, both in terms of dig rate and spot time, and safer as well. As you can see, the likelihood of a video-verified microsleep when operating in the red is up to 14 times higher than that likelihood when in the green. Other metrics further confirm the relation between lab-validated predictive data and real-world observed performance. Now, let's dive in to ReadiAnalytics. ReadiAnalytics is a business intelligence tool dedicated to fatigue insights. ReadiAnalytics enables leadership teams, operations teams, and health and safety and environment teams to assess a baseline of worker fatigue throughout an organization. So as a leader, you can see fatigue at a macro level. From there, you can identify fatigue hotspots within crews or shift patterns, really starting to understand when and where fatigue is at its most severe, and why. And then ultimately, what ReadiAnalytics allows you to do, like any analytics tool, is track progress of specific initiatives, in this case, fatigue reduction initiatives, against relevant and meaningful targets for your organization. ReadiAnalytics makes fatigue quantifiable, and therefore makes it actionable at a macro level, and helps you drill down to areas that need fatigue reduction initiatives the most. Ultimately, ReadiAnalytics enables you to drive outcomes in productivity and safety. With ReadiAnalytics, insights can be based on either schedules alone or a combination of schedules, wearables, and manual sleep input. The configuration options are many, and ReadiAnalytics is designed to fit your needs and the culture of your organization for fatigue management. So let's dive into a demo. So here I am in ReadiAnalytics, looking at data for a fictional company called Mindco. Here within Mindco, you can see I'm looking at data to start in the historical section. In this example, data has been gathered from wearables primarily in order to provide meaningful, personalized estimates of fatigue across 5 different locations and many subgroups that have been configured within those locations. I'm going to start on the left-hand side here by looking at a simple snapshot of fatigue. And I'm going to look at it for my most basic configuration, the day shift and the night shift. I can simply choose a date range from there, and as I hit submit, a chart for the fatigue risk profile of my organization will be calculated and appear. So what are we looking at here? Well, in a fatigue risk profile, what we're looking at is the percent of time that is spent on duty on the shifts that I've selected in a state of high risk, elevated risk, moderate risk, or low risk. Each of these risk categories corresponds to the Ready scores of the individuals in the hours they were working on duty in the analysis period. For instance, overall, during all shifts that were worked in the month of March that I've selected, 26% of the hours observed, or 7,543 hours in this case, were worked in a state of high risk. As you can see, that compares to the total hours of 2,585 work hours that were analyzed from 161 users who in this case were wearing wearables that provided sleep data for the purposes of calculating a ReADY score. Now this is an overall snapshot, but the numbers don't mean as much without important context. For instance, is 54% of time spent on duty on night shift high, or is it to be expected based on the intensity of the schedule? The same could be asked for day shift. So ReadiAnalytics automatically calculates meaningful targets for each shift based on the nuances of the schedules that have been inputted. Essentially, this is a very valuable tool that uses both rules-based and machine learning-based algorithms to determine how would a good or ideal sleeper tend to sleep if subjected to the schedules these individuals were subjected to. And what percent of time would such a good or ideal sleeper be spending in a state of high risk? Fatigue is unavoidable in certain circumstances, so the answer isn't always 0. So in this example here, while the actual percent of time spent fatigued was 54%, the expected percent was only 27% if everyone on crew were a good sleeper. So that provides some perspective on the contribution of the schedule and the contribution of sleep health to these data, and it does so in a way without exposing named personal sleep data. Similarly, ReadiAnalytics provides an overview of sleep metrics at the crew level. So I can see, for instance, that only 11% of individuals, or 21 out of the 184 sampled, are getting on average 7 hours or more of sleep a night, and even fewer are spending the recommended 8 hours in bed. So I can start to drill down and understand if sleep quality, efficiency, or quantity are at play in terms of issues. Now, as I work my way down, we'll return to the category of trends in a minute, but I'll show you how you can drill down at a deeper level across comparing different groups and locations, really starting to understand where fatigue is the most severe and where fatigue may be less of an issue relative to other places. So here I'm simply looking at a comparison not only of all 5 locations, but each of the groups that have been set up within those locations. And immediately I can identify that Greenville is among the most fatigued of all areas, with the 6 users sampled showing high risk, occupying about 83% of their time on duty in the sample period. Similarly, I can isolate just the high risk levels for a clearer view, and I can notice right away that the electrical crew in Fairview might not be the area that I might start with if I'm implementing a fatigue reduction program. I might focus where the need is highest in Greenville or perhaps operations in Bristol. But drilling down doesn't end there. I can look at, of course, these same metrics, these same charts for sleep quantity, efficiency, and time in bed, while preserving the privacy of individual data, look at how individual groups vary by quantity, quality, or time in bed at a personal level. Or I can ask the question, perhaps Greenville, for instance, is just subjected to a more severe schedule. Is that what's contributing the higher risk? Well, with actual versus target, I can really compare each schedule to the observed performance. And in this case, I can see that while 16% of time was expected to be fatigued, 83% was actually fatigued, revealing that the schedule didn't really contribute in this case significantly more to the fatigue of Greenville than other locations. And I can isolate that view to see the variance even more easily there. So finally, in terms of drilling down to the data, there's concentration, where each bar, and this can be anonymous or it can be showing the names, reveals the individuals and their performance relative to expectations. So as you can see here, there are 5 individuals on the far left who are spending nearly all of their time fatigue impaired, with each bar representing an individual, whereas their schedule would suggest only about 16 or 15%, depending on the schedule, of time would be expected to be fatigue impaired. I can view general fatigue risk profiles for a clearer view as well, and really see the skew. So in this group, about 26 of the 161 individuals are spending over half of their time fatigue impaired. And those on the far left, the top 20%, are accounting for nearly half of all time spent fatigue impaired. So different organizations handle these insights differently, whether it's reaching out directly by name or telling individuals at large that there are resources available to help if you continue to see on your own personal data fatigue at such elevated levels. Either way, organizations have been able to achieve significant reductions in fatigue by making resources available to address fatigue not only at the individual and one-on-one level, but by approaching groups that are having significant levels of fatigue, and at the group level, providing resources such as sleep education or diving deeper into areas of potential improvement. Areas such as providing better sleeping quarters, providing improvements in different routines related to the start and end of shift, other things that can improve fatigue in terms of small changes that can over time make a large impact. So with these areas of potential ways to understand fatigue better and finally quantify fatigue, what's really important then is that whatever initiatives you implement, that you start to see an improvement over time in the fatigue levels. And that's where trends really comes in. Trends helps you understand what programs are working and what programs are not working. And of course, as I load trends, I can see here, not only trends at an aggregate level for my entire organization, but I could drill down, for instance, and select trends at just a single location or a single group. Now in this example, fatigue decreases dramatically over the course of a month to illustrate a point, but more likely, and what we see in the real world, is fatigue decrease significantly over the course of about a year. Programs take time to implement, and expectations need to be realistic there. But what's important about this is not only looking at trends over a long period of time, but also understanding for certain purposes and certain analyses how fatigue changes from shift to shift. So with schedule overlay, you can easily see a string of 4-day shifts in a row, or a string of 4 night shifts, or how fatigue progresses over a shift rotation. You can even see how recovery works on off days to isolate fatigue at that level as well. In fact, you can even drill down to fatigue at the hourly level, zooming in on fatigue at a very fine level to look at the performance of individual crews or groups hour by hour and to pinpoint hotspots. And perhaps the most compelling chart to enable this is grid view. What grid view enables is an at-a-glance heat map of fatigue across an entire roughly month of time at once, so you can easily identify which periods historically have shown the greatest fatigue. You can even refine your analysis for much greater insight. For instance, I can filter to just show fatigue during work hours, and I can instantly see here that out of roughly this entire month of time, the most fatigued several hours in this case were about 3 a.m. On March 15th and March 16th. So as I think to the future and try to plan similarly, I can take the insights here and I can actually have the system forecast where fatigue is going to be most severe into the future. Using the historical analytics combined with the schedules that have been inputted for the future, each crew receives a crew level heat map of where fatigue is going to be most severe. So supervisors can plan to allocate the most complex tasks to the times of the month with the greatest green, and avoid the times that are in a shift pattern with the most red. Do less safety-sensitive tasks during those times, based on real historical data that is being used to inform future scenarios. So ultimately, this is just scratching the surface of some of the things that can be done with ReadiAnalytics. And returning to objectives, ultimately it's about helping you as an organization understand when and where fatigue is present, understand what you can do about it by getting to the root cause or causes of fatigue, and as you implement real-world programs to try to reduce that fatigue, understand what's working and what's not working. And our customers have seen significant results from using these data-driven strategies to drive meaningful fatigue reductions. In a case study from a major mining customer, aggregate fatigue exposure, meaning time spent in the red, decreased by 21% over the course of a 14-month period. And of the most fatigued 230 to 250 individuals, approximately 80% of them sustained a significant improvement in their fatigue over that time period. And ultimately, less time in the red and more time in the green means not only safer experiences for your workforce, but also an expectation of greater productivity. From a case study with another major mining customer, we found not only that microsleeps correlated 14 times higher to time spent in the red, but that spot times and dig rates, two meaningful measures in a mining environment of productivity, were about 3.2 to 3.3% better when an operator operated in the green versus that same operator in the red. So ultimately, when you think about data-driven decision-making as a component of your fatigue management strategy, think about ReadiAnalytics, which enables you to see fatigue at a macro level, identify areas for improvement, and drive specific strategies that can lead to a reduction in fatigue, an improvement in safety, and an improvement in industrial productivity. Thank you.